Okay, let's start out with Campbell's question number 18. So for this one, you're supposed to use the hinge theorem or its converse and the properties of triangles to write and solve an inequality to describe the restriction on the value of x. So basically, we have to come up with an inequality for this, okay? So when we look at number 18 here, we can see that these three sides are all marked congruent, right? We have AB, BC, and CD are all marked congruent. So when we use the hinge theorem, we have to know that the two triangles have two congruent sides. So we're going to know that this side here and this side, that's our one set. And then we'll know this one by another set is another set of congruent sides in the triangle. And the hinge theorem concerns the angle between them, right? So sorry, not that angle. So, oh yeah, sorry, that is that angle. So it's the angle between the two sides, the included angle between those two sides. And then we can look at the opposite sides there. We can visually tell that this angle here, this angle ABD, is a larger angle than angle DBC. So we can tell that that's the bigger side. So when we set this up as an inequality, we're going to say that that's greater than. And then you're just going to solve for x. Does that make sense, Campbell? Okay. Alicia, did you get that whole explanation? Okay, good. Let's see. So Madison, number 16. Number 16 is going to be the same way. When we're looking at this one, we have to set up our inequality. We have our side measures there, so we can see that these two sides and this side are our congruent sides, okay? So we need to find a measure for that angle there, or for that x, okay? So we know if we look at the sides that we have here, they go with these angles, right? And according to the hinge theorem, the one with the largest measure is across from the side with the largest angle, or it's across from the largest angle, okay? So if we look here, 15 is the largest measure, so it's going to be the largest angle, or across from the largest angle. So when we set this up, we'll have 2x plus 5 is less than 66, because 2x plus 5 is going to be across from the smaller side. And then you just solve for x. You're welcome, Madison. And then Natalie, number 10. Oh, Natalie left. Okay. Okay, Natalie, I think I've got it now. So if we look at number 10, it says the path from E to F is longer than the path from E to D. And then the path from G to D is the same length as the path from G to F. So we know this and this are congruent. What can you conclude about the angles of the paths, and then explain your reasoning? So we also know that this side is congruent here, okay? So we've got this one and this one, and then those, okay? So that's our two congruent sides. The problem also tells us that E to F, so this length is longer than E to D. So if we know that this is the longer side of the two, and this is the shorter side, then we can apply the hinge theorem here and say that this angle, angle EGF, is the larger angle. Does that help? Does that help, Natalie? Okay, good. Okay, Charlotte Ann, so for 14 and 15, we need to use the hinge theorem or the converse, and then try and solve the inequality to tell what a restriction would be on the size of x, okay? So if we look at number 14, remember the hinge theorem says that if you have two congruent sides in two different triangles, so that's the first thing. So if we look at 14, do we have two congruent sides? Well, we know that we have these two sides, right? And then we know we also have that side there that they share. So those are our two congruent sides. So we can apply the hinge theorem here, okay? And then what it says is that the side, if you have two angles included between those two sides, and they're different measures, okay? So see, we have one that's 70 and then one that's 65, that the side across from the larger angle is the longer side, and the side across from the smaller angle is the smaller side, okay? So on this one, the way that you're going to set up an inequality, remember inequality is greater than or less than, we're going to be able to say that x is greater than 7 because we know the side with x is the longer side and the side with x is the smaller side. Does that make sense? So then we're going to do the same thing over here on 15, except there's going to be a little more work to do. So on 15, we have a congruent side here and here, right? And then we also have this side in the middle. So the angle that's included between those congruent sides is going to be our 30-degree angle here and our 38-degree angle. So which side is going to be longer? The side that has 3x plus 2 or the side that has 12x minus 7? Yeah, the side with the 12x is going to be the longer side because it's across from the largest angle. So when you set up that inequality, you're going to put that side is greater than the other side. And then you're going to solve for x just like a normal equation. Okay, so number 16 says you and a friend are going shopping. You leave school and drive 10 miles due west on 26th Street, and then you drive 7 miles northwest on Raspberry Street to the grocery store. Your friend leaves school and drives 10 miles due east on 26th, and then drives 7 miles southeast on Cascade to the movie store, because there's so many of those around still. Each of you has driven 17 miles. Which of you is furthest from the school? So if we look at this, we're going to be able to apply the hinge theorem because we see we have this side and this side are congruent. And then we also have this side and this side are congruent. So we have two congruent sides and two different triangles. And we are concerned with these angles that are between them, okay? So we've got a 100-degree angle and a 120-degree angle. So the path that we took, or that you took, is to go from the grocery store, or sorry, from your school down 26th and up Raspberry to the grocery store. Your friend did the other direction, which was this way, okay? So they want to know which is longer. This from the grocery store here to your school, or from your school down to the movie store. If we apply the hinge theorem there, remember the hinge theorem says that the side opposite the largest angle is the longest side. So which line there is opposite the largest angle? Well, so which angle is bigger, 100 degrees or 120 degrees? Okay, so 120 degrees is bigger. So the side that's directly across from 120 degrees is going to be the side that's the largest, okay? It goes with what's directly across from it. So your friend who went to the movie store is going to be the one that's the furthest away from the school. Does that make sense? Okay, good. Okay, Charlotte, and let's start with number 16 because that's the one I had pulled on the page closest, okay? So if we look at 16, we're supposed to use the hinge theorem and find a value for x. So remember what the hinge theorem says. When you have two triangles that have two congruent sides or two pairs of congruent sides, then the angles between them are different measurements. And you can apply that to see which is the longer side, okay? So if we look at 16, we have two sets of congruent sides, okay? We see that this 12 and 12 here are congruent. And then we also know that this one is congruent because of the reflexive property, right? So what we're concerned with then are the angles between those two sides. So that's this angle here, and then this angle here. Now, we do have side measurements over here. So which of those sides is longest, 13 or 15? So if 15 is the longest side, then according to the hinge theorem, which angle is going to be the largest angle? Yes. So you're going to set up an inequality and say 66 is greater than the other angle, which is 2x plus 5, and then solve for x. Does that make sense? Okay. So then the next one you needed help with was number 5. Let me pull that one up, okay? Okay, Charlotte Ann, so if we look at number 5, we need to say if TR is less than, greater than, or equal to UR. Sorry. So if we look here, we have to look at the two triangles we have. Now, can we apply the hinge theorem to those two triangles? Yeah, you can, because you have the two pairs of congruent sides, okay? So then what we're going to deal with is those two angles that are notated there. So if we look at those two angles, which is the bigger angle? So which side is across from that 24-degree angle then? Yes. So UR is going to be the bigger side because we see TR is across from the smaller angle. So does that mean TR is less than, greater than, or equal to UR? Yep, that's right. It's less than. Okay, Charlotte Ann. So if we look at number 10, this is going to be the same for 10, 11, 12, and 13. We're supposed to match the conclusion on the right-hand side, so A, B, C, or D, with the given information. And you don't have to explain your reasoning on this, okay? Just give me the letter that matches. So if we look at 10, it says AB is equal to BC. So let's mark that. AB is equal to BC. And angle 1 is greater than angle 2. So angle 1 is the biggest angle and angle 2 is the smallest angle. Now, these triangles also have this little, this shared side here that would be congruent as well. So we can apply the hinge theorem there. So if we do that, then we're going to be talking about, we see we're talking about angle 1 and 2. So we're going to be talking about those sides that are directly across from those two angles. So which of those sides would be the biggest? Okay, and then which one is the smallest? Yes. So AE is your bigger side and EC is your smaller side. So do you see one of those things on A, B, C, or D that says that? Yep, that's right. Number 10 is D. Good, I'm glad. You're welcome.